All right, well, welcome everyone to the Networking Masterclass for the month of June. We're going to go ahead and kick off the webinar and get started. So thanks for taking the time to join us today. We have a lot of good content. This is all about public cloud and a lot of the newest features that we have available in the public cloud. Remember, if you have any questions from today, and if for any reason we're not able to get back to you, you can always email us at networkingmasterclass@citrix.com. So at this point, you should be able to hear me. And if you're having trouble with the audio, or perhaps I'm not coming through clearly, you may have a better experience changing from computer audio to a phone call, or from phone back to computer. It just all depends on what kind of connectivity you have and where you're at. If you want to try out a phone call and you're not seeing the country code or a dial-in number for your country, you can always click on problem dialing in to get a list of additional phone numbers available for the webinar today. Next up, this is a live webinar, and we really appreciate engaging with you, our audience, as we go over and discuss the content with you today. So if you have any questions, I invite you to post your questions into the chat panel or the Q&A panel on the control panel of your webinar. And we'll try to get back to you during the webinar itself today, or even have the presenter directly answer your question during their presentations today. And as I mentioned earlier, if for any reason something pops into your mind after the webinar, or if there's something we can't get back to you on today, we invite you to email us offline at networkingmasterclass@citrix.com. Finally, this session is being recorded, so if you need to step away, or perhaps you'd just like to watch the content again, or perhaps even share it with a colleague, rest assured that we will be sharing a link to the recording of today's session following the webinar later this week. So who's with us today? I'm your host and also presenter today. I'm Dave Potter. If you're new or don't recognize my name, I'm a senior solutions architect at Citrix. I've been around for quite a while, and I typically host our other sessions of the Networking Masterclass. And today I'm hosting this one for the European session. Joining us today are guest presenters, Hari Haran and Jas Garrett, and they'll be discussing and sharing with us all the great new things that we have coming out in our public cloud offerings, both on the Citrix ADC side of the house, as well as on our SD-WAN side of the house. And also today, we had a last minute addition, so joining Hari will also be guest presenter Mayur Vadar. So what's our agenda today? I mentioned it's all about public cloud. So that's why I've got everything under the spotlight. So the way this will work today is we're going to talk about first about what's newest and coming out in the public cloud. And this will be all of Hari. He'll show us some of the current deployment topologies and recommended ways of deploying the solutions when you have multiple active locations in multiple sites. As we see a lot of people moving to the public cloud, it's no longer just one site, one public cloud. It's multiple sites and maybe even different public clouds. Rounding out Hari and Mayur's introduction of new features, I'll be going into and covering a live demo showing some of the ways that we can use ADM to automate the provisioning of services in different public clouds, as well as how you can deploy the application onto those provisioned services. So here we're taking advantage of ADM as an orchestrator and showing you how to do the provisioning and app configuration in multiple public cloud locations, all within ADM. After the demo, we'll be talking to you, and Jas Garrett will be showing us what's new and complete with SD-WAN in the AWS public cloud specifically. So stick around, you're going to see a lot of new content on the ADC, ADM, and even a brand new feature that just came out last week on SD-WAN. And then rounding things out at the end of the hour, maybe a little bit past, I'll be covering some news and views and revealing what our topic will be for the next month in July. So the topic today is something that was suggested by you, our audience, and we always appreciate when things that you come to mind and you share with us what you'd like to see and when we're able to deliver those topics. So we invite you, if you think of any other topic that you'd like to hear about in a future networking masterclass, we invite you to either shoot it over to us in the Q&A or chat panel, or email us at networkingmasterclass@citrix.com. We love your feedback and we love your ideas for future topics, keeping the content as clear and as relevant as possible to you, our audience. All right, with that, I'd like to introduce Hari Haran to cover our first topic today, which is all about ADC in the public cloud, and more specifically, what we're doing brand new. So with that, Hari, I'd like to bring you online. Can you hear me?
Yes, Dave. Good morning, good afternoon, good evening, folks, wherever you are.
I can hear you well, Hari. I'll go ahead and make you the presenter.
Yes, and I'm going to share my screen. Dave, you're able to see my screen?
Looks great.
Perfect. Thank you so much. So, friends, today I'm going to cover the public cloud updates, and there are also some automation updates that Mayur will share with you all, right? With that, my first update here is going to be on AWS cloud. So what are the new things that we brought in last quarter, right? One of the primary thing that we did on AWS is to support private IP-based HA solution, right? So a lot of our customers wanted that. They are on AWS, but they also have a IPsec tunnel between the on-prem and the AWS or AWS Direct Connect. So they want to make sure that our HA solution works with the private IP. Our first HA solution was totally based on the public IP. Now with this, you will be directly able to provide in GitHub. We also have a CFT template wherein you will be able to have the HA pair using a private IP, and the private IP movement will happen between the primary and secondary. So as the pictorial representation clearly shows that when the traffic is flowing through zone 1, which is primary, and there is HA failover happens, the new primary will be the secondary, the old secondary one, which is depicted in the bottom. You clearly see, as we have shown, that this can be in two availability zone, zone 1 and zone 2 of the AWS. As you can see that the zones, you can choose between whatever the zones are available on AWS. In certain regions, AWS provides 4 zones, certain regions it provides 6 zones, so you can choose the zone yourself where it needs to be deployed. And for this deployment, we also provide a GitHub repository. A CFT is there over there. The link is shared over here. So once you go to the GitHub repository, you'll be able to invoke this whole setup or deploy this whole setup using the CFT template provided. So this is one of the important updates that we delivered recently on AWS. Going to the next thing, as you may be aware that we had output support back in 2020 itself. One of the important things that came from our customers were how to support an active passive deployment using GSLB. So we used to have within the AWS region, which is a public cloud, we used to support GSLB. Now look at it, having a public AWS cloud and having an outpost, which is a kind of an on-prem solution from AWS, we both can now have a GSLB integration in the form of active or active passive deployment. So as more and more of our customers are slowly moving to the AWS public cloud, we have seen that they also want to be having the same ecosystem wherein AWS provides public cloud and also the same sort of software as an outpost in their own data center. So with this approach, now our customers will be able to utilize the AWS control plane to manage traffic between these on-prem and the public cloud itself, right? So it is of your choice whether you want to go for an active deployment or an active passive deployment. This is also very well documented as provided here, the hybrid cloud deployment with AWS, and we do have a VPX on AWS Outpost separately if you want to just concentrate on AWS Outpost itself without going to the public cloud. But as far as you need to have a control plane or AWS account to manage your outpost as well. Our third update on AWS is a quick start that we created for how to configure web application firewall in AWS. This is a very detailed deployment guide. Once you go over there, we just talk about the WAF, various features, and WAF and bot management, and how to configure that using a CFD. It's quite detailed, quick start guide that we can have, and it is embedded with the CFD where the deployment itself happens. So one of the new things that we did in the last quarter. And one more update was with regards to the smart deployment. The smart deployment, that now we also have a demo video that we have, and how the smart deploy works to simplify the whole Autoscale deployment in 3 steps. So that is also an important update. As you know, our Autoscale solution works with Citrix ADM, and which provisions the ADC and also can connect to an Autoscale group within the AWS and make sure a kind of a backend autoscaling works with our solution. So the ADM will be able to manage the ADCs on the AWS to scale in and scale out, and it will also work with the Autoscale group within the AWS to make sure that the new web servers that are spun on AWS are automatically added to the service group on AWS. Now moving on to the other updates here, this is with regards to Azure. As you may know that in kind of Q4 back end, we started supporting accelerated networking. This was a major ask because accelerated networking brings in low latency, higher throughput in scenarios. So we always recommend that when you are deploying ADC on Azure, please use or enable the accelerated networking. So, and this was true for more than 2 VPX of 200 Mbps, right? So with accelerated networking, a previous limit was around 250 to 300 Mbps per NIC. That was the throughput per NIC that was supported. So hence we used to ask our customers to have at least 3 NICs for going close to 1 gig, or even 6 NICs for going to 3 gigs. Now those limitations are not there. Now the limitation only comes from the instance of Azure itself. As you can see on the right, I have taken a screenshot of the Microsoft or Azure documentation, wherein it clearly depicts whether the accelerated networking is supported for a particular instance or not. Once it is supported, then it also has an expected network bandwidth, right? So we always make sure that whatever the license that you have for VPX also correlates with the Azure instance, which shows a particular expected network bandwidth over here. Let's say, for example, you want to have a VPX 3000, which is a 3 gig throughput license. Then for that license, you cannot have a standard D4S V4 instance, which has a maximum throughput of only 2 gig. So in that case, you need to install a standard or deploy a standard D8S V4 to get that throughput of 4 gig. It can support a throughput of 4 gig, which is more than the 3 gig license, right? So that's one thing. The next thing is that apart from the low latency that the accelerated networking enablement provides, the one more benefit is that now we can reach up to 10 gig per VPX. Depending on that, you need to choose the appropriate instance for sure. In this case, if you want to have a throughput of 10 gig for a particular VPX instance, you need to use an Azure instance of standard Z32F, which can support up to 16 gig throughput. For that matter, you'll be also able to install a 15 gig license on the instance standard D32S V4, even though it may not support maximum throughput of 15 gig, but because of the higher PE counts that we provide for that particular license, we will be able to, or the customers will be able to have more ICA throughput, more SSL throughput for that matter. Moving on to the next update on Azure was Azure Stack. So we, in the Q1 of 2021, we released Azure Stack support. There was one thing pending was publicly available the Azure Stack offering. So we made sure in the last quarter, we did provide an update wherein now Azure Stack offer of Citrix ADC is available publicly. So anybody who is having an Azure Stack will now be able to see the Azure Stack Citrix ADC offer in the Azure Stack marketplace. With that, it also brings the same capability that AWS has now. You can use an on-prem site which has an Azure Stack Hub and a public cloud Azure, and you can combine it with GSLB over there in an active passive or active active scenarios, right? So it's the same thing that we discussed on with AWS. Now moving on to the very important piece that we did this quarter is the smart deployment. As in case of AWS, we started smart deployment in Q2 for Azure as well. With the smart deployment now, it is just 3 easy steps to configure ADC Autoscale on Azure. With the ADC Autoscale on Azure, you can see that there are two things that Azure brings to the table. One is configuring your Citrix ADC on availability set and configuring Citrix ADCs on availability zone. In case of availability set, you can create a 32 node cluster on the 3 availability sets combined, right? But in case of availability zone, each availability zone in Azure, you can have a maximum of 32 node cluster. So on an availability zone deployment, you will be able to maximum configure 96 node Citrix ADC cluster or in an active scenario. And on availability set, maximum you can configure is a 32 node cluster. So this is also a very important update that we wanted to share. Moving on to GCP, this is the important thing that we started supporting in Q2 of this year is the support for Autoscale on GCP. So this has been pending for a long time. Finally, we have the support of Autoscale, and this is through ADM. So via ADM, now you will be also able to configure the Autoscale on GCP. With that, what I will do is let Mayur talk about Red Hat automation.
Thank you, Hari. Good day, everyone. This is Mayur from ADC Product Management team, and I have a couple of automation updates, very interesting one. So the first one is Citrix is now a certified Red Hat Ansible automation platform partner. So this is very big news to any Ansible users over here. So those who are new to Ansible, Ansible is a open source automation tool provided by Red Hat, right? And using Citrix ADC Ansible modules, you can automate ADC configurations like different features like load balancing, content switching, GSLB, WAF, and everything, right? So using these modules, you can define the playbooks, what we call in Ansible terminology as playbooks, where you just define the target or the desired ADC configuration. And what these modules will do, it will fire appropriate Nitro API calls to achieve that state in your ADCs, right? So that's a very preferred and declarative way of automating configurations in ADC, and Ansible helps you to achieve that. Now, talking about the certification, we announced this over a blog a couple of months back, but what does this certification means is that this ADC Ansible modules are very much validated by both Citrix and Red Hat team, and are very much designed to run on enterprise automation, run for enterprise automation. Other than that, these modules are available in cloud.redhat.com, right? So this particular modules the certified modules are available for users who have a Red Hat Ansible automation subscription, right? So those customers who have this subscription can go to cloud.redhat.com, search for Citrix ADC, and they can download these modules. And the important part for it is that this Ansible modules would be supported by both Red Hat and Citrix team. So if you find any issues with that, you can raise escalation or file a support ticket with Red Hat, and then Red Hat and Citrix can coordinate to resolve any kind of issues that you face. But apart from that, even if you're not a subscription customer, you can find this ADC Ansible modules in our in the galaxyansible.com that we have the link over here, or you can also refer to Citrix source repo in GitHub. So a lot of customers are using it from this GitHub repo to use it. And at the below, if you're new to Ansible, then I encourage you to try this out. We have very sample configuration playbooks over here for different use cases. It won't take more than 15-20 minutes to get your first configuration through Ansible, and you can explore the capabilities that Ansible brings to you. Next slide, please, Hari. Great. So another great news is now Citrix ADC Terraform provider is live in Terraform registry. As you can see on the right side, this is HashiCorp registry where all the different providers are listed, and Citrix ADC got listed just a couple of weeks back. Basically, the biggest advantage of getting listed in registry is that you don't have to do any sort of manual installation of our Citrix ADC provider. You can just write a snippet of code and it will automatically install during the runtime, right? That automation is part of this HashiCorp registry itself. Another part is that updating it to our latest version will be very, very easy if you use our Terraform modules from the registry. And also you can integrate them as part of any kind of automation workflows you have, such as CI/CD. Now, again, those who are new to Terraform, Terraform is again open source automation tool provided by HashiCorp. It takes as an infrastructure as a core and declarative approach to automation. What do I mean by declarative is that you just define the target or the desired state of your ADC, and it will fire the right appropriate APIs to configure your ADC configurations. So using Terraform, you can configure various ADC use cases such as load balancing, GSLB, SSL configurations. Everything you can configure it and configure it through automation. Again, we have a lot of sample ADC configurations available here in GitHub repo. You can take a look and you just need to modify the end values. And again, it won't take more than 15-20 minutes to get your first configuration through Terraform, right? So this was all about Citrix ADC configurations. Now, Terraform can also be used to deploy Citrix ADC. And we support deployments in public cloud like AWS and Azure as of now, and GCP will be coming soon. So using Terraform, you can deploy ADC in standalone or even in HA configuration. And these scripts are a little bit different, and they are hosted in different repository, as you see here at the below. These are in Citrix/Terraform cloud scripts. So you can make use of these scripts, and what it will do is it will create your AWS infrastructure required. It will deploy ADC and then configure ADC in HA or even in standalone configuration. So that's again very powerful way of deploying and configuring ADCs where all your configurations are stored as code, and it can be hosted in GitHub repo, and you can track all your changes over the time and have better control to your infrastructure.
Thanks,
okay, with that,
I also wanted to add that now we also do support BLX. If you're interested in bare metal ADC, now we have Terraform scripts to configure or deploy BLX, and also configure your LB VIP or GSLB options via Terraform. So if you're interested, please do let us know on that. Thanks, Mayur, for the update. And Dave, now you can run the poll. You can take control.
Sure. So I'm just going to go ahead and launch a quick poll. And what we're interested in is which factor is most important to you when evaluating your ADCs in the public cloud? Are you looking for something that's simply easy to use? Are you looking for something that's advanced, perhaps something with security features or advanced routing policies? Are you looking for something that's very high performance. Perhaps you have a lot of traffic that comes in bursts in the public cloud. Are you looking for something that just has a lower cost to get into it, or TCO? Or perhaps maybe there's some other reason you're looking for this. Maybe you just need to have different locations. So would like to get your feedback on this. It looks like just about 30% of you have voted. Would just like to get a quick feel here to see if you are, what's really the driving factor to you for bringing your ADC into public cloud. All right, we have just about half of you voted, so I'm going to go ahead and close the poll and share out the quick results here. And it looks like for the majority of you, the reason and the most important thing for you in evaluating your ADC in the public cloud is that it's easy to consume. So the integrations here, specifically which we shared with Terraform, looks right like it is in line with what your expectations are, followed closely by the lower cost to operate, as well as the advanced features. All right, back to you, Hari.
There is one more poll question.
Sure, we can run that one.
Yep.
So today we, Hari and Mayur talked about mostly in Azure, but there's also the AWS and GCP public clouds. So we'd just like to get a quick feel here. We run this periodically and the answers change, believe it or not, by the month. And so what we're curious to understand here with you in our audience today is which public cloud are you using the Citrix ADC in? Assuming that you've already started your public cloud journey and are using a Citrix ADC in there, are you primarily using AWS? Are you in Azure? Maybe doing a forklift operation where much of your operations and existing infrastructure is moved into Azure? Or are you using the brand new GCP for its advanced compute capabilities? Or perhaps maybe none of those public clouds, maybe you're using a private cloud offering. So again, it looks like just about half of you have voted. So I'll go ahead and close that out. And it looks like by far, the majority of you are using Azure, which I think is right in line with the ease of use. In my experience, going into AWS requires a little bit of retooling. And then sometimes changing the way that a lot of your services work in order to take advantage of AWS. And GCP is continuing to grow. So it's interesting that about a fifth of you are already on board with GCP. And then of course, a few of you in the other segment of private cloud perhaps. And it's always exciting to see that you're using ADC not only in the most common areas. All right, that's the end of the poll. Do you have anything else, Hari, before we transition?
No, we just want to thank our customers over here, and Dave, you can take over.
All right, thanks so much. All right, everyone. So at this point, I'd like to give a little bit of a hands-on feel for what you just saw. So Hari and Mayur showed us everything about brand new features in AWS and Azure, and specifically how to automate deployments using Terraform. Now, I would love to show Terraform in a future webinar, but for today, I'm going to show you something that's a little bit easier to consume. As you mentioned, ease of use was your highest or top priority in adopting public cloud. So for the demo today, and what I'll be showing you in the next, say 15 minutes, I'll be showing you how to provision an Autoscale group of the Citrix ADC using ADM in the public cloud. So in this case, I have an ADM service subscription, and I've linked my subscription to the three most common public clouds, Azure, AWS, and GCP. And I'll show you just real quickly what it looks like to provision a brand new Autoscale group. Now that is a cluster of ADCs in the respective clouds. And the reason we like clusters is just saving the cost and the total cost of operation in the public cloud. You won't have an active node that's not being used. For example, when you provision an Autoscale group, all nodes will be active, and ADM is responsible for adding or removing nodes. So I'll show how those features are configured from ADM. Then I'll be completing the deployment by showing you how to provision an application into the Autoscale group, again, using ADM and specifically a Stylebook. And then rounding things out, this would not be really very valuable if you were only deploying this in a single site or a single location in public cloud. And so I'll be showing the final bit here, which is how to connect a single application into multiple public cloud locations, all driven from ADM. All right, so to kick things off, I have, this is my ADM service account, and I have a couple Autoscale groups created already, and I'll be coming to these or coming back to these when it comes to provisioning the service, mainly because it takes a little bit of time for these to be provisioned out. So in order to provision a VPX or an ADC cluster in a public cloud, the first thing you'll want to do is go into ADM service, go into your Autoscale groups, and then we're going to add a new Autoscale group. Now we have three options available today. You can provision a cluster in AWS, in Azure, and also in GCP or Google Cloud. Now, Azure was the most common cloud of your preference in our audience today. So I'll go ahead and show the demo. I have all three added to my subscription, but I think maybe in keeping things most relevant, I'll show you what we have specifically in Azure. So the first step here is to create an Autoscale group. And the first thing that we'll need to do is give it a name. I'll just say my Azure Autoscale group, and I'll give it a number 2. Now the next option here is the site. And this was chosen because I've actually already linked my subscription with Azure. So in this case, I've already linked a cloud access profile to my location in Azure, and specifically I would be deploying this in the central US location. You're not restricted to that. In fact, anytime that you link your cloud access profile into Azure, and I'll just show how quickly and easy that is to do. To create a cloud access profile, you would go in, give it a name, and then using information from your Azure subscription, you would go in and fill in the remaining details, specifically your tenant ID, which is your Azure AD directory, the subscription identifier, as well as a provisioning resource within Azure. Now, this provisioning resource needs to be owner or contributor within Azure, and then the secret key in order to access that service. This final 2 fields are used by ADM service to provision the new VM resources in Azure in the above subscription. So once that information is filled out, then you'll have the ability to select the cloud access profile, as well as the sites that are registered for that access profile. In this case, I've already connected my cloud access profile, and I've deployed an ADM agent to manage the VPX instances in this site within Azure. The final piece here is to choose a login profile for your ADC instances, and then whether you want to use Azure ALB or if you want to use Azure Traffic Manager, Azure DNS, to distribute traffic directly into your ADC cluster. Now, a lot of our customers immediately wonder, why are we front-ending an ADC cluster with an Azure load balancer? Why not use Azure DNS? And the difference is simply because in terms of being able to quickly handle a rapid onflow of traffic, or perhaps deprovisioning of a cluster node, if you expect a lot of changes in the scaling of your service, it may make sense to front-end it with Azure ALB in order to quickly transition between additional nodes and removing those nodes rapidly. If you'll be scaling periodically or infrequently, then it may make sense to use Azure DNS and to save the cost of by not having to run Azure ALB in front of your VPX cluster. The choice is yours. Using DNS, there is some significant delay in the amount of time that a client would look up the name and get the IP addresses of each individual VPX in the cluster in order to access it. Azure ALB provides a rapid transition. In terms of the high availability for the cluster that you deploy in Azure, we give you the option of either deploying into an availability set or an availability zone. Now, I realize that these sound very similar, but they are actually quite different in terms of the technology that goes into it. The availability set is basically provisioning the cluster nodes within a single data center, and availability zones is within different locations in a region. So every time, every location, say the central US region here for this site, every site within Azure will have 3 availability zones. So think of availability set as deploying your nodes all in a single availability zone, and the zone would be in 3 different locations in a metropolitan area. So in this case, I'm going to choose all 3 nodes just to have the most level of availability. And then in terms of the tags, say this Autoscale group, if it were being provisioned for a specific line of business, you could include some organizational specific details here, which transfer into the resource descriptions as the VMs are deployed in Azure, allowing you to keep in line things like if you do any kind of billing or any kind of resource management within Azure, having the tags available and provisioned by ADM allows you to track those resources as they're consumed directly in the public cloud. The next option is to choose the parameters, when to do the scale out and when to do the scale in operation. If you're a little confused by these ranges, I find it more convenient to look at the summary. When is the scale out happening and when is it scale in? Down here in the text, really the scale out happens when any one of these conditions is met. And these numbers are the right-hand side of the scale parameter. So anytime the CPU exceeds 70%, memory is above or highly utilized, or I have a lot of throughput being used in the cluster, then we'll go ahead and add additional nodes to it. Similarly, when it's time to scale in, all of the available thresholds need to be met. In this case, everything needs to be below 30%. Now I can adjust these as needed to custom tune my cluster, or perhaps I don't really care about memory. Perhaps I just want to monitor CPU and throughput. Those options can be enabled or disabled as needed. Over on the right-hand side, we have some basic parameters for the cluster itself. How many nodes do you want to start with? When do you want to add a node? And when do you want to start bringing nodes offline to reduce the capacity if you no longer need those additional nodes? And then we have a special box here in case you have or expect a rapid surge in traffic. Perhaps a lot of customers are coming in all at once. Perhaps everyone needs to access the service at the same time or comes into work or comes online at the same time. It may make sense to keep a spare node running in the cluster but not yet receiving traffic so that if we need to do additional provisioning of additional nodes, then we'll have that spare node available, and adding it into the cluster is just a matter of increasing or adding it into the load balancing rule for ALB or for the DNS. The next part here is to choose the license. Now, whether you are a single entity providing your own licenses, if you've already switched to pooled licenses, we provide the ability for ADM to license out the VPX instances in the cluster. Or if you're a service provider, we provide you the option to allocate the license directly from the marketplace in the cloud. Both options have their value and their advantages. If you want your customer to directly cover the subscription and the license to run the VPX in their own subscription at their own pocket, you can always allocate the license directly from the cloud. In order to do that, you would select cloud and then one of the licenses available from the marketplace. But if you already have your pool of licenses, you can always choose to do bandwidth or pooled based on the capacity in your existing pools in ADM. And then you can choose whether to do capacity, or if you have our legacy perpetual licenses, check-in, check-out licensing. And then finally, the features that are available in this Autoscale group. Now, at a minimum, you'd probably be looking at doing something like advanced to do global server load balancing, or premium if you're deploying this, as I noticed, as your need was for advanced layer 7 features, probably looking for something like some WAF policies, web application firewall, or DDoS protection. To get that, you would use the premium license and then select the amount of capacity that you want to allocate to the cluster. The final pieces here are to choose which VM size you'd like to deploy. Some of our customers prefer deploying many smaller cluster nodes to reduce the total cost and to only consume the resources in bytes or incremental sizes. But if perhaps you're expecting infrequent scale, perhaps to minimize the disruption to users during scale operations, you can always choose to deploy a larger image. Along with that, we give you the option of which release that you'd like to choose. And we upload only the current release, and we provide that as a convenient dropdown. But if you're still running a different release, perhaps of the application that you want to support is still only qualified with version 12.1, you're always welcome to add your own custom release version, and ADM will go ahead and deploy that into the cluster nodes on demand. We provide additional features here like the number of NICs available for your deployment. A typical best practice is to use 3. We continue to recommend that as a best practice to separate your management, the client side from the DMZ, as well as your internal servers. But if you're looking to do this in as small of a footprint as possible, you're always welcome to use a single NIC as well. And we see that happening much more common in the last half year than we have seen previously, probably because it's a little bit easier to manage, although it does make the security concerns a little more interesting because your firewall policies and your security groups need to be very carefully managed. Once we choose the number of NICs, the final check here is to choose the security groups for everything. In this case, I would say for my management, I'll go ahead and put my management in the ADM DMZ service group. For the client facing, I would choose my public service group. And these are service groups that have already been created and exist in my Azure public cloud subscription. The final piece is then to choose the subnets. Now I've already created a VNet and I've added a few subnets into my VNet. And these dropdowns are the names that I've created in my subscription already for the demo today. So in keeping line with management for my first NIC, I'll go ahead and choose that, public for my second NIC, and then private for the third one to reach my servers. And that's all that's needed to deploy an Autoscale cluster. So the final bit here is to click Finish, and that kicks off the deployment in the cloud. Now, if I wanted to show you this live, the total deployment time is about 15 minutes. So rather than go through all of this, it looks like there's a little bit of an error here. I left something, I guess I forgot to check a box here on one of my models. Now, this complete process can take between, it's really up to the public cloud. In Google, we're seeing this deployment take as little as 5 minutes. In AWS, it's pretty quick as well, 5 to 7 minutes. In Azure, I'm seeing anywhere between 5 and 20 minutes on average, depending on just the time of day and what resources are available in that zone that I'm creating this. Now, ADM is orchestrating everything for me, so it's going to create all of the services that I've defined. It's going to push down the new image. It's going to get the IP addresses, deploy the resources. In this case, I chose ALB, and all of that's going to be created for me in real time. Now, we're not going to watch that live on this demo. I'll save you the boredom of the time. Typically, though, this will run between 5 and 15 minutes. In the meantime, what I'd like to show is an application or how to deploy an application on these nodes. Now, I mentioned GSLB multiple sites. In my environment, I've already configured an Autoscale group in Azure, in AWS, and in GCP, just like what I kicked off here in at the beginning of my demo. To deploy an application onto one of those nodes, I would then go under Configuration and then add an application to the node. So in this case, the application would be a basic, say I've got a web server in my cloud subscription. I just want to make it available into the cluster. The next step here is to add. And then we'll go ahead and give it a name. So we'd say Azure Autoscale Group App 2. We'll go ahead and choose the Autoscale group. In this case, my first one's still being provisioned, so I'll go ahead and choose the one that already exists. Now, the interesting thing here that I want to call out is using ADM to do the provisioning, you can choose whether the application is externally available, and ADM will request a public IP to support the application, or if you just want it to be available to your internal location and customer and sites, or perhaps you choose or you would like to provide the external access manually using a firewall or another device. You can make that choice here by choosing either internal, external, or none. If you don't want any kind of access set up, you'll do that or finish off that provisioning on your own. You can integrate with your existing domain name if you'd like to do that, or you can choose the auto-generated domain name. I like auto-generated because it just keeps things completely automatic from a point of proof of concept, but you're always welcome to do and define things custom. And then if you'd like to support it with SSL or HTTP, you can choose that at the beginning as well. The next step is once you define the framework, how is the application going to be accessible? The next step is to choose a stylebook to support the deployment. In this case, we have some stylebooks available for Autoscale. In this case, I think the easiest one to get a web application available is just to choose your basic LB Monitor Autoscale one. I'm just choosing the one indiscriminately here, the one that's the highest version. If I need to add monitors, maybe layer 7 policies, I can choose a more complicated or feature-rich stylebook to support the application as needed. Now, what goes into the application stylebook? We've really taken a step back and tried to simplify this to get the application online as quickly and as easily as possible. So the only thing that we're asking for here is any advanced settings that you'd like. Perhaps you want to do some header insertion. Maybe you'd like to change the LB method. You can do that as well. Because this is Autoscale on the front end, we provide two kinds of service group definitions in the back end. First of all, if you already have your application server deployed and it's a fixed resource, you could put in the static IP of that application. If it has a registered domain name, you could use that instead. So for example, if I only know it's 172.16.10.20, I would put that IP address in. If I know this as myapp1.company.com, I would put in the name as well. I could use that instead. If I put in the FQDN, the ADC cluster will continually resolve that name into an IP address when load balancing connections to it. So if that application server might change locations or VNets, and its IP address might change as well, it might be important for you to use the FQDN in that case when provisioning the stylebook. The other option here is cloud. Now, cloud is interesting because if your application itself is say an Autoscale group of servers in Azure, that would be a virtual machine scale set. In AWS, that would be just a server Autoscale group. If you want to support that on your back end, you would just type in the name of that Autoscale group, some basic parameters, and then ADM will go ahead and look up the IP addresses that are in that Autoscale group that are being used and plug them in automatically and resolve them into the service group definition when this stylebook gets deployed. Then the final bit here is if we're talking SSL on the back end, you can upload the SSL certificates for this server to round out this stylebook deployment. And that's all that goes into completing a stylebook for an Autoscale group. Now, I've already completed some stylebooks in my Autoscale group. So if I go ahead and back out of here, I want to show you what that looks like. So I've already deployed an application in Azure. So I'll just go in there real quick. I've deployed this using an external type, and it's auto-generated, and it's just a real basic configuration. In this case, I've just said I've got one server running in my Azure subscription. I chose static just for the point of simplicity. And when that got deployed, ADM went into Azure, added an external IP address, and then provisioned all 3 cluster nodes with that stylebook. If I wanted to see how that stylebook is performing, or if I just wanted to access it, I would be able to, I can always go in, look at what cluster nodes were provisioned and any details associated with that operation. And if I just want to get access to it right now, if you scroll all the way to the right in the Autoscale Group Configurations tab, you'll see either a name or an IP address belonging to that application. So if I wanted to access this application right now, I would go ahead and plug this in to my web browser and I would be able to go to it online. However, because this demo is all about Autoscale groups and multiple sites, now I've got my application in multiple sites, how might I be able to connect a front end or a common name to both the application running in Azure and also one that's running perhaps in GCP or AWS. So in order to do that, we'll switch over to the application Stylebook. Now, what I'm using for this application Stylebook is not an Autoscale group Stylebook, and there's a slight nuance and difference. An Autoscale group Stylebook goes to the cluster nodes that I just deployed. An application Stylebook will go to an existing deployment of VPX nodes. In this case, I have two standalone VPXs deployed, one in Azure and one in AWS, running GSLB, and I've already configured MEP. So if you're already using a Citrix ADC to do your global server load balancing, and you add them into ADM as managed instances, it's possible to use an ADM Stylebook to add the front end and configure GSLB on those two nodes to access our newly configured application that is in an Autoscale group in our new Autoscale nodes. So go ahead, so what does it look like to add a new application? So in this case, if we want to make this application available as a GSLB or Global Server Load Balanced application, I would go in here and say application name, Global Load Balanced Stylebook. Now this is the easiest one to involve multiple clouds. It's a little bit different than the GSLB Stylebook, which gets involved in doing GSLB where the VPX that I'm provisioning the GSLB service on is also load balancing a local node. The GLB Stylebook has no such requirement. So in this case, because my Autoscale group is independent of the VPXs that are doing GSLB, I've chosen the multi-cloud GLB Stylebook to incorporate multiple cloud instances. So in this case, we'll go ahead and punch in and type in some basic details. So in this case, I would go ahead and say, I want my GSLB app to be available as, say, my app one is the denomination. We'll go ahead and say just basic round robin, just so that we can see multiple IP addresses being used. Go ahead and give it a name. And in this case, the domain name is the fully qualified name of the application. So in this case, you would use something like myapp1 and then the FQDN or domain name of your organization. The final piece here is to plug in the site for your GSLB configuration. Now in this case, I've already configured my two nodes, one in Azure and one in AWS. So I go ahead and give it an internal IP. Now this IP is the ADNS or GSLB site. So I've already configured this, and I would expect anyone configuring GSLB applications to already have this configured in their infrastructure. If you don't have this already, then you need to stand up two or more VPXs, or perhaps your MPXs if they're in a private data center, and you would need to have GSLB set up with MEP. So go ahead and match up a site name to create Azure. And then my second site, and this would also be, now this one would be for my second location. So my second location is in AWS. You notice I have a different CIDR block and a different public IP address. And those are the two front-end locations for resolving DNS for this application name. And now pulling it all together is pushing the Stylebook to my different ADCs. Now I have all of my ADCs in my account in my lab, but I've labeled two of them specifically that do GSLB in the two different locations. So if I want to configure my new application to be load balanced with these two different nodes, I would go ahead and select these two and then click create. Now at this point, my load balanced node is being, GSLB site is being provisioned on the two load balancers. And if I punched everything in correctly, I would see all of this coming through absolutely correct. And so I'm a little bit embarrassed to show an error live, but this would not be so much fun for all of us if it just went as flawlessly as possible. So obviously I had a deployment error in my application configuration. I'll take some time offline to go through this, but basically what I'm seeing here is that there was a problem provisioning the final policy so that I can resolve DNS for the application that I provisioned earlier in my Autoscale group. Had this completed successfully, I would be able to switch over and show you the GSLB policy, show you how it resolves, and you could see that I'm now able to access the application from my point of entrance in Azure and my point of entrance in AWS, an application that is configured within an Autoscale group, all done by the front end from ADM service. All right, so that wraps or concludes my demo showing how to provision an application, basically provisioning cluster nodes, 3 nodes within Azure, provisioning an application, an Autoscale application on those nodes, and then how to make it globally accessible from 2 different points of access, all within or being led by ADM itself. So if that looks interesting for you and you'd like to get started, I invite you to go ahead and go to log into ADM service if you have it already. If you haven't quite used ADM service, maybe you use ADM, you'd just like to see how it works for you, you can always go to this shortcut here. This is a URL that we don't have published anywhere else. So you're really seeing this just on this webinar alone. You can go to the URL. The title is onboarding.cloud.com. And if you go there, you can sign up for a cloud.com account with Citrix, as well as activate a free trial or a free subscription of ADM service to get started with provisioning. The next step, once you log in, is then to launch ADM, at which point you'll be able to add in your ADCs and kick the wheels, see how it works for you, and access some of the features that I shared with you today. All right, so that's what I've got on ADM service and for Autoscale provisioning. At this point, I would now like to hand it over to Jaskaret to round out our webinar with our final topic today, which is all about the Citrix SD-WAN and what's brand new and exciting with what our latest feature for the SD-WAN in AWS. And specifically, it is our newest Connect feature, which is using the Transit Gateway. So with that, I'd like to bring Jaskaret online. Can you hear me, Jaskaret?
Yep, yeah, I can hear you fine.
Right.
Can you hear me okay?
Yes, I hear you well. I'll go ahead and make you the presenter. And I can see your screen.
All right, that's great. Thanks, Dave and team. So hi guys, good afternoon and good evening to everyone. So I'm Jaskaret. I'm one of the product managers on the SD-WAN team, and we are going to talk about the newest functionality. We launched it actually a couple months ago. This is GA now, but before that, we'll just touch a little bit upon SD-WAN, and then I'll walk you through what this integration means, what is the business benefit, what use cases it targets, and towards the end of it, I have kind of recorded a video for the demo, how this feature functions, and I hope that this would be useful to you. Okay, so to start off, right? I mean, what has been changing very rapidly in this world is that the workforce it's kind of distributing itself into work from home and also office. I mean, it's more work from home today, but I think eventually will kind of evolve to a model wherein the workforce will be split across locations. There are going to be people who are going to be working from home and and office as well, right? So what happens in that scenario is that there is a little bit of a lack of visibility. For some statistics, 44% of organizations say that remote worker employee desktop, they don't understand what's going on and what's going on within it, and likely see them as a threat vector or an attack vector to their enterprise. The networks, they have kind of evolved, or they have kind of been evolving from a DC-based hub and spoke model into a cloud model, wherein the applications, they are not only hosted in data centers, they are now moving into cloud or moving into SaaS applications. So it's more of a full mesh sorts of a network rather than a hub and spoke. And it seems that the networks, they're still designed the old way, wherein the traffic does not usually break out from the branches into cloud and into wherever the workload is. It takes a backhaul route from to the DC, and then from there goes out to the internet. That's one way how the erstwhile networks have been designed. They're not designed to keep pace with the increasing cloud nature of applications and workloads, right? And it seems that 55% of the enterprises feel so, and this is a statistic back from 2019. My best guess is that this number would have gone up, especially after COVID, and especially after the fact that the cloud adoption has jumped dramatically, because it gives you an immense amount of flexibility in order to bring up resources and tear them down based on demand. And since the workloads have kind of spread and the applications have kind of spread across multiple locations, be it cloud and in DC and on-premise and SaaS, the infrastructure has not been able to keep pace with it, and in some cases it was designed in such a way that making any changes to it made it even more complicated to manage and understand. So they're like infrastructure silos in networks. A network can do one thing but can't do another, and if you want to kind of change it, then it requires immense amount of effort from the broader team. So that's all is kind of the reality that the enterprises are facing right now. So that brings the question that what can help simplify it. So SD-WAN is one way with which you can simplify it. With regards to solving the first problem, wherein the user could be anywhere, user could be at home, or user could be on the move, you kind of need a solution which is kind of which fits both the bills, which fits both the use cases for home worker as well as for branch office solutions. Right? And then you are kind of going to evolve to a design wherein it's in most cases what we have understood that usually it's not a lift and shift from DC based infrastructure and DC based app to cloud. It's more of a hybrid scenario wherein you still have some apps residing in data center, but you still have but you're increasingly increasing the use of your workloads in cloud and in SaaS, right? So it's a hybrid model. You're going to have your applications in data center as well as in cloud and as well as in SaaS. So you kind of need a policy, like a central policy that can govern, which traffic goes where, and can control the routing. So if it's a DC hosted application, you need to be able to configure a policy and say, hey, this application is hosted in my DC, and I want this to be accessed over a certain route from the branch to the DC. And for some traffic, such as Office 365, which is a very well spread network, by the way, and it kind of means that there is a POP closer to you wherever you are located. So it makes sense to break that traffic out directly from the branch itself into Office 365, so that the user experience does not suffer on account of the increased latency if you were to send it from the branch to the DC and then break it out to internet. So with all that, you kind of need a centralized management framework which can dictate how the policies are going to behave, how the traffic is going to be routed, what kind of security policies you're going to have for workers who are working from home versus workers who are working from branch office. What kind of encryption you're going to have, whether you need to have any specific kind of security models for workers who are at home, and you need any specific routing policies based on where the worker is. So all that can be controlled from a single SD-WAN pane of glass. We like to call it the SD-WAN orchestrator, which is a cloud hosted and managed solution. And regardless of where your apps are, regardless of where your workers are, it can kind of be the one and be all for everything related to your network, right? And one supreme value add that SD-WAN adds to the mix is that, regardless of where the worker is, you can make use of multiple links to ensure that there is 24/7 uptime in order to reach to wherever the application is, right? You can also use 4GLD links or 4GLD you can just insert in front of the appliance. It's as simple as that. And the system just starts to use it. So no matter if even if the other link goes down or suffers from a brownout scenario, you still have a way to reach out to wherever your workload is, as long as it's a public workload and it's reachable over public lines. So and in that direction, the overall SD-WAN market is kind of evolving into a SASE. SASE market with the security and kind of converging. If you're not familiar, then SASE is a term that was coined by Gartner a couple of years ago. It stands for Secure Access Service Edge, which means which essentially is a fancy way of saying cloud-based security, right? So essentially, the SD-WAN as of today supports both forms of security. You can have a next-generation firewall embedded into the appliance, or you can also make use of a Citrix hosted Citrix on cloud service for security. Very similar to Zscaler. So on that regard, we got some favorable reviews from Gartner, which ranked us #1 in terms of application optimization and ease of deployment. And you can have the SD-WAN deployed in all three clouds, all three major clouds: AWS, Azure, GCP, and in data centers and at home. And in terms of each value addition to cloud workloads, we can, because of the breadth of features that are available, regardless of where the workload is, you can have it accessed over the SD-WAN. Okay. So that's a high level brief into SD-WAN. So I just wanted to get a feel for if you are currently using any form of SD-WAN or thinking about using SD-WAN, right? So if the poll is open, please answer yes or no. Okay, so Dave, can you check if we have received some responses?
Yeah, we got about 30%. I think we're pretty good there. So thanks for the feedback on that one. And then you probably want to run, do you want to run our second one?
Yeah.
Right.
So if you are, right. So if you're wondering about investing in SD-WAN, is SD-WAN one of the wonders that you're thinking of? Is it on your list, or is it not at your list?
Cool. Looks like about a third of you are interested. Very good to see that. Very encouraging.
That's good. Thank you, guys. Okay, so now we'll jump to the meat, right? And that is to tell you a little bit more about what the enhancement, what the feature is all about. So so if you're not familiar, I'm just not going to just give you a brief of what the transit gateway is. So transit gateway is think of it as an intelligent router that exists in AWS, right? And the problem that it solves is to allow you to maintain like a centralized routing table, centralized and automated routing table, which allows you to kind of send traffic from one VPC to another VPC. It's an extremely useful feature, especially if you have multiple VPCs in different regions or different across the globe. So this was announced, I think, a couple of years ago, the transit gateway piece, and at that point we had IPsec based connectivity available to use SD-WAN and to try and connect to transit gateway. The enhancement that is available today is for a feature that is called Transit Gateway Connect. So it's an addition to the Transit Gateway component. So this allows us to host an SD-WAN appliance within the same VPC where the Transit Gateway is hosted, right? And we would be able to talk to the Transit Gateway over GRE and also be able to exchange routes over BGP. So let's say if one of your VPC goes down, that route is going to be exported into SD-WAN, and we'll automatically learn that this is the VPC to which we no longer need to send traffic, or if there are any changes in the network, we'll automatically get to learn that. So it's going to exist in the same VPC where the Transit Gateway is hosted. So that's on the AWS side. What does it mean on the WAN side? So it means that this SD-WAN virtual appliance will always be able to talk to orchestrator and be able to connect to your other SD-WAN appliances that are at branch or at home or wherever the data center is, and gives you the flexibility to use the virtual path technology that we have, which allows you to use multiple links, bond them together, and give you the per packet load balancing experience that is unparalleled in the industry. Right, and all of this can be controlled from a single pane of glass of SD-WAN orchestrator. Right? So we'll look a little bit deeper into how the functionality, how the feature functions video. But from a use case standpoint, this is what it means for you. So you can use multiple links from one branch or from home users to access your workloads that are in AWS, and by virtue of that, avoid backhauling the traffic from the branch to the DC, right? And of course, if you are using the virtual PAN technology, you get per packet load balancing and dual ended costs. The next generation integrated firewall is also integrated onto the appliance, and all of this is managed via a centralized pane of glass that is the SD-WAN orchestrator. Okay. So we'll quickly jump into the demo, but let's take a look at what the topology is going to look like. So herein, this is how our topology is. So we have a connect VPC. This is where we are going to provision a couple of SD-WAN instances, and the reason is for HA, primary and secondary mode. These appliances are going to talk to a transit gateway component, and this is the piece that we will create automatically using the workflow defined in SD-WAN orchestrator. And behind this transit gateway, we have a couple of VPCs within which we have a couple of VMs, and towards the end of the demo video, we'll see if we are able to send traffic from these VMs to the SD-WAN appliance in AWS and back on to the on-premise DC. Okay, so let's quickly play the video. Okay, so took a look at the. Okay, so here's what we are going to do. So we are going to first pick that we are going to use the service, and for using the service, we got to authenticate SD-WAN orchestrator with AWS, and we do it by means of secret key. So we have already provisioned a site, the VPX appliance in AWS. This is the site that we have available in Northern California region. We'll go quickly check if there is a transit gateway attached, transit gateway available in this VPC region. This is one of the transit gateways, and we will kind of assign it an attachment tag. This is user defined. We'll pick the VPC within which the transit gateway is available, and the reason to do that is to make sure that we pick the right addresses. We'll pick the subnet, and we will just first deploy the VPC attachment. So at that point, we have a VPC that can talk to the transit gateway. Then we'll pick a GRE CIDR block for the transit gateway. This is to enable the communication between the SD-WAN appliance and the transit gateway. From this CIDR block, we are going to use one IP as the peer IP on the transit gateway side. We call it the connect peer GRE tunnel IP. This is the IP over which we are going to use to peer with the transit gateway. The peer address is the IP address of the SD-WAN appliance. Pick the BGP CIDR block and assign whatever you find relevant. And this is just a screen that kind of gives you a summary that which site you're connecting to, what is the IP of the SD-WAN VPX in AWS, which is the region, what is the IP to which you would be connecting to, and what are the BGP IPs over which BGP routes will be exchanged over what ASN. So once we have this, we're just going to save this configuration. And in order to make this config active, we have to go via the SD-WAN change management process, which is just to we'll push this policy to our entire network and to the VPX that is available. So we can see here that the appliance is up. It is connected to orchestrator, and now what remains to be seen is if we are able to send traffic over it. So in order to see whether we are able to send traffic, we're just going to go into the report section, and let's see, pick the latest data and see if we are able to exchange any routes, if the routes are being exported into SD-WAN. So for instance, this is the service that was named by default. We didn't create this service, that it automatically got created in the backend once you push the service, once you push the configuration, and we see that over this particular GRE tunnel service, we are able to see that the routes are getting exchanged. Right. So let's see if we are able to send traffic. Right. So we can see that traffic is being sent. The number of packets that keeps on incrementing. Just to be double sure, we'll see if the WAN link usage is also increasing. So yeah. So this means the traffic is being sent over the WAN links that are configured in AWS, right? So looks good from a SD-WAN perspective. We are able to see traffic being sent, and we are able to see it in orchestrator. Okay. So now we'll quickly log into the AWS console to see the same thing, just to verify the flow from both ends. Looks like the transit gateway peering is up. Let's just quickly check. Right. So which means that the BGP peering has been established. The tunnel, GRE tunnel is up. And if we go to the network manager, we can see that over the bar star, the traffic, we're able to see bytes in and bytes out, which means the traffic is flowing via the SD-WAN appliance and via the transit gateway. And fortunately, there are no routes, no packets dropped or black hole. Okay, so yeah, I mean this brings us to the end of the short demo video that I had planned. So I hope it was useful. Please feel free to drop some questions if you have in the window. And if you have follow-up questions, please feel free to reach out to me. And of course, we'll be sharing both the video as well as the slide deck.
Well, fantastic. Thanks so much, Jaskrat, for sharing that. We did get one question, and that is if somebody has already, this person has already begun their multi-cloud journey, and in fact, were an early adopter, so they're already using the Cloud Direct Connect and site-to-site VPN to connect their different VPCs. In their case, they're curious, how can they migrate or take advantage of the transit gateway? Can you just briefly cover what is a way that one might be able to migrate from one technology to the other?
Right. So if you are using Cloud Direct already, then I mean, and if you want to make use of the transit gateway feature, the simplest way to do that is to just host a VPX appliance in AWS, right? And you could either use this automation or you could provision things manually. So this would do good for you in terms of accessing resources over AWS, right? It does not solve a problem for SaaS access, right? Which Cloud Direct does, right? So I mean, you may still want to be, let's say, invested if you if one of the reasons for you to invest in Cloud Direct was to optimize access for SaaS workloads. The transit gateway would be a good solution for accessing your workloads that are hosted in AWS or for some SaaS apps that are hosted in AWS, but primarily for those workloads only, not for SaaS apps. So I think that there are two ways that you can use this. I mean, first is if you are using the SD-WAN today, you can either establish IPsec tunnel right from your branch appliance into transit gateway, which means that the traffic traverses IPsec from your branch appliance into AWS. You won't be able to make use of the virtual path functionality, and you would lose the per packet load balancing features and application visibility. So that's one way if you want to try it out. That's the simplest way that you can achieve. And the other way to get like end-to-end SD-WAN is to host a VPX appliance in front of the transit gateway connected to your branch appliances, and then from the VPX appliance in AWS, establish IPsec tunnel or a GRE tunnel if you're using this feature to transit gateway and start using and accessing your workloads in AWS.
Well, that is fantastic news. So thanks so much, Jaskrat, for the great insight and for sharing exactly how to make such a solution work, even if we're not all blessed with ability to have the transit gateway rightly immediately available. So thanks so much for sharing with us today, and we really appreciate you coming on the webinar. Thanks so much, Jaskrat.
Thank you, Dave. This was really good. Thank you.
All right, everyone. So that rounds out our hour on SD-WAN, and now I'll just cover what's new, what's coming out this month that we didn't already cover. So if you were lucky enough to join us last month in May for the masterclass, we covered a brand new feature that would be coming in ADM service. And it was all about security advisories. Basically, what we've introduced is the ability for ADM service to scan all of your managed Citrix ADCs and provide you with a list of options. So we show if there is a version that you're running that's a little bit older, we'll go ahead and show you how that's vulnerable. What are the CVEs that match on that device? And then directly within that workflow, we'll give you the ability, or ADM will give you the ability to upgrade that device if you want to upgrade it on the fly in that workload. Or if you'd like to do it later, you can also create a config job to do it at some other time. Now, because that was in last month, we did qualify the new feature with not yet released, but I'm happy to say that that is coming out within the next 7 days. So look forward to, or if you're interested in getting started with ADM service, perhaps trying the Autoscale Groups, you'll also be able to take advantage of that new feature that we introduced just last month, all about being able to find what vulnerabilities are existing on your fleet of Citrix ADCs when managed by ADM service. Also brand new is a blog that Sanyukta, who presented the content last month, has come out with. And in this blog is all the nice detail on how to walk through basically managing an ADC and then finding out what the vulnerabilities are. And so in this blog, Sanyukta provides a visual workflow of how to go through that within ADM service, kind of like a mini demo in blog format. So I invite you all to go to citrix.com/blogs. If you search down under application delivery and security or networking tags, you'll find this blog written up just in the middle of April. All right, so that's the end of the content that we have today. Thank you everyone for joining us. If you're interested in coming back next month, we would be really excited to share with you all about Citrix ADM, but as it relates to a brand new and more current technology, which is all about what we had formerly considered or classified it as cloud native networking, or more recently, we're now calling it app modernization or modernized apps. So these are all apps that run in the Kubernetes environment in container services. And we have a lot of new features within the Citrix ADC and ADM product lines that address how to manage and monitor and rapidly automate the configuration and provisioning of those services, even in the public cloud, not just on private cloud. So if you're interested, perhaps you have some apps moving or migrating from monolithic type services that run on virtual machines into a more lightweight container-based application service. We invite you to join us next month for the spotlight topic of modernizing your apps on Citrix ADC using ADM as a manager tool. We'll also have an interesting case study about how to deliver a security-based posture using the Citrix Secure Internet Access implementations, also in public cloud. So if you're interested in either of those topics, I invite you to join us again next month for another big release, a burst on content as it relates to modernizing applications in Kubernetes container-based services in the public cloud, as well as a case study showing how one person is taking advantage of that today as our customer. All right, well, that's it. So thanks so much, everyone. That brings us to the end of another networking masterclass. And it remains only to thank the great crew of our presenters for their time and for sharing with us today all of the great content. And of course, thank you to our audience for sticking around and making this so much fun with your questions today. I'm Dave, and until next time, we hope to see you again next month. Bye-bye.